Hi everyone. Recently, I've decided to completely rebuild the dialogue system in Vibrant Venture. The current system is outdated and I've been wanting to rework it for a while now to be able to include special text effects, dialogue choices and many more customization options. So today, we're going to be doing just that. To start off, we first need to realize that a system like this is simply impossible with Unity's built-in text component. This is because we cannot change the position of each individual character with Unity's text component, which means it's impossible to create any cool shaky or wavy effects. We could use a different asset called Text Mesh Pro, which allows us to create customizable high-quality mesh fonts, but we're not really interested in that because the game is pixel art, so using HD fonts would probably not really fit the style. Besides, the more handmade our system is, the easier it will be to expand upon in the future without having to rely on some Unity component, and also it's a lot cooler. So we're going to be making our own system using sprites to display each character, which is extremely customizable via code and shaders. Admittedly, it is a lot more difficult to create our own system like this, but I like having cool text effects, and also I like creating my own system and not having to rely on others. So, let's get to it. This approach poses many interesting problems, however. First, we need a way for the computer to know which sprite on the sprite sheet corresponds to which character. To solve this issue, I created an array of characters which has the same fixed order as the sprites do on the sprite sheet. That means the first sprite in the sprite sheet is an A, so the first character in the array is also an A. This is very convenient because we can then create what's known as a dictionary, which is just a list containing keys and corresponding values. If you're unfamiliar with this data structure, you can think of it as a table with two columns where each element in the left column points to an element in the right column. For our use case, the keys will be the type char or character, and the value will be the structure containing the sprite of this character. That way, when we use the character A as a key in the dictionary, it returns a structure containing the sprite of the letter A. However, knowing which sprite to use for each character isn't enough. We need to know how wide each character is in pixels, otherwise we risk the characters being too close or too far apart, which would lead to some very hard to read dialogue and ugly spacing. This problem could probably be solved in many different ways, however I chose to develop an algorithm which automatically detects the width so that we can change the sprite sheet in the future if we need to. Here's how it works. For each sprite, we perform a vertical scan starting in the top left corner until we hit a non-transparent pixel. Then we perform the same procedure starting in the top right corner. That way, we can find out where the sprite starts and where it ends. When we've got these two positions, finding the width is a simple matter of just subtracting the leftmost pixel position from the rightmost. We then add this width to the same data structure containing the sprite data so that we may access this piece of information just as easily. This whole procedure is only performed once when the game first boots, and the data is then stored in memory to be easily accessible. Now, in order to store the dialogue text itself, meaning the text we wish to display in the dialogue box on screen, I made a simple object which contains a text field array that we can edit inside of Unity, and I can simply change this number here to define how many dialogue boxes I want, and write whatever I want inside of them. The code can then iterate through these boxes to know what text it needs to display. Now we've got all the information we need to start displaying text on screen. We first need to have the text show up in the dialogue box with proper spacing. This is a rather simple matter of looping through each character in the dialogue object and drawing the corresponding sprite on screen using our previously discussed dictionary of characters and sprite data. Every time we draw a sprite, we increment a position value using the widths we calculated so that each sprite is properly offset from the previous. This works really well, but it's quite boring to look at, so let's talk about effects. The first effect we want to create is a Typewriter Effect, which types out each character one after the other. A naive approach would be to wait a constant amount of time between each character, but this is going to cause problems since every player will have a different frame rate. Some players may only have 20 frames per second while others may have over 100. So how do we ensure the writing speed stays the same across all devices? This gets a little bit tricky, so try to stay with me. I came up with a solution where we have a number starting at 0, and then for every frame, we increment this value by the time since the last frame multiplied by some constant that determines the writing speed. Basically, this just means that if your frame rate is very high, This value increments in smaller steps, but more frequently than if your frame rate is low. This concept is known as delta timing, and some of you may have heard of it before, but if you're new to programming or just computers in general, this concept may be a little bit confusing. All you need to understand is that it ensures that the value increases at the same rate, regardless of your frame rate. We can then use this value as a means to measure how many characters we need to draw the next frame. For example, if the value is 5 now and was 3 the previous frame, we know we need to draw 2 sprites, because 5 minus 3 is 2. Therefore, the dialogue will always be written at the same speed, even if your game runs slowly. We just draw multiple characters every frame if the game is lagging to effectively simulate the speed being the same across all devices. Likewise, we don't draw a sprite every frame if the game is running at a high frame rate, because then we might end up drawing, say, 60 characters every frame if the game is running at 60 FPS, which means the effect would be way too fast. Alright, so far so good. Now let's talk about custom effects like shaking text and waving text. I decided to use tags to determine which parts of the dialogue should have which kind of effect. Here's an example of a wave tag, which I signify with the character W, where the text inside the tag, this text right here, should wave. And as you can see, the syntax is very similar to common markup languages like HTML. Obviously, this doesn't just work by itself, since it's going to assume the tag is part of the dialogue, and therefore draw it on the dialog box along with the rest of the text. We need a way for the code to read these tags. So I made a custom tag parser using some basic string manipulation, which essentially just activates a flag when we're inside a tag, and then resets this flag when we exit the tag. It also ensures that the tags don't get written on the dialog box. When this flag is set, it means that we're inside of a tag, and so we simply add the next set of characters to a list, and this list will just end up containing all the characters that we want to animate with the effect specified by the content of the tag. Then we simply go through this list every frame, and we perform a basic math formula in the sprite to create the desired effect. For wavy text, I used a basic sine function to make the characters move up and down smoothly over time. For shaky text, I pick a random direction to offset the sprite from every frame, and here's the result. We can easily expand upon this tag system to also allow custom colors, so I did that, and here's how that looks. It's very easy to add even more effects, so I'm going to be coming back to add more in the future. Let me know if you have any ideas for cool effects I could add. How about we add a way to respond to the dialogue? Here's what I did. Each dialogue object contains an additional array of response objects. These objects consist of 2 fields. The text to show, for example, yes or no, as well as a reference to a separate dialog object. So basically, when I click yes here, it then feeds the code the reference dialog object, which then shows its dialog and any response that it may have. This actually allows us to chain infinitely many dialog objects in whatever order we want, and effectively creates a node system. Now, it may come as a surprise to you that I'm actually quite lazy, so I'm not actually going to make a node system. Instead, you can just click this field here in order to go to the object it's pointing to, which honestly I think is a lot easier to understand and get an overview of instead of these super complicated and weird node graph systems. I don't like node systems. And there we go, the dialog system is pretty much done. I went ahead and added a few animations to polish the visuals, and I also added an option to display the dialogue with a little tail to imply speech. And this tail actually follows the speaker as well, so if they're moving around, the tail is going to track them. I may have gone a bit overboard with how flexible the system is, since Vibrant Venture is no RPG. I hope it was interesting to follow along and get an idea of how the new dialogue system works, and hopefully you learnt something new as well. Of course, there are many technical details I skimmed over in order to save time, and because it would probably be really boring to hear me talk about things like optimizations and core routines and class management, so I decided to go with a brief and general explanation instead. If you've got any questions or feedback, please let me know in the comment section below, or join our Discord server, link is in the description below. Make sure you like the video if you enjoyed this type of content and would like to see more. It's been really fun to make this sort of technical insight, and this is a video format that I've never really done before, so please let me know if there's something that just doesn't work. Thank you for watching, and until next time, take care.